Hello and good morning to students. Here we are in the lecture of statistics, part 1, linear correlation, chapter number 2. I am Sanjay Dattani with you. In this video lecture, students, we study the short sums which are asked in linear correlation. In the previous video lectures, students, as you all aware, we take the different methods of linear correlation. We take the concept of correlation, types of correlation, positive correlation, negative correlation. Briefly, types of correlation, that is perfect positive, partial positive, perfect negative, partial negative, and lack of correlation. Then we studied the three methods of linear correlation, and that is scatter diagram method, Karl-Pearson's method, and Professor Spearman's rank correlation method. We take the sums of scatter diagram method as well as Karl-Pearson methods. In Karl-Pearson method, students, we take three types of sums in previous video lectures. First, when x bar and y bar both are in integer way, the method of x minus x bar, y minus y bar. Additional 5 columns we prepare in that particular method: x minus x bar, y minus y bar, x minus x bar into y minus y bar, x minus x bar square and y minus y bar square. Then we put the formula and get the answer. Then students, we take the sum of xy method, in which the digits are small, generally less than 30. We prepare the three columns xy, x square and y square. We put the formula and get the answer. Then we take the sums of UV method, that is shortcut method, in which 5 additional columns we prepare: u, v, ub, u square and v square. Then we put the formula and get the answer. After doing this big sums, friends, today I am in this particular video lecture would like to explain you the short sums which are asked in linear correlation. Short sum means students, we do not have to prepare any additional columns. Just we put the formula, we write the formula and put the values. Different values are provided in the question sum. Just we have to put that values into the formula and definitely we get the answer. Such sums are called short sums. So students, please open your page number 85 of exercise 2.2. Today I would like to teach you sum number 12, sum number 13, sum number 14 in this particular video lecture. So students, open your textbook and keep your attention on the board. Now, first we take sum number 13. The sum number 13, here it is the sum. In the question they ask, find the correlation coefficient from the following information of rainfall, that is x in centimeter, and yield, that is y, tons per hectare for the last 10 years of a district. They provide us n is equals to 10. They provide us covariance xy. Covariance xy is 30. SD of x. Here SD means not Sanjay Dattani. It is standard deviation. Standard deviation of x, which is called SX5. they provide us the variance of y. Variance means sy square. See, we studied it in standard 11th. Variance means square of standard deviation. Square of SD is called variance. So here variance of y, that is called sy square 144. So we have to find the value of sy, and the value of sy is under root of sy square, that is 12. Square of 12 is 144, under root of 144 is 12. We need SD of y, that is standard deviation of y. That's why we find the under root of y, that is 12. Clear? Now we find correlation coefficient. Students, when I explain you the different formulas of correlation, if you remember properly, or you observe your list of formula, in list of formula, I give you the different lines that which formula can applicable in which situation. In that particular list, I explain you, I write one sentence, when covariance xy is given. See your list of formula from your book. One sentence is there, when covariance xy is given. When covariance xy is given, the formula to find the correlation coefficient is R is equals to covariance xy upon Sx into Sy. Covariance xy upon Sx into Sy. Here R is equals to covariance xy, that is provided in the question. It is 30. So I write here 30. Sx means standard deviation of x, that is also given 5. So I put here 5. Sy we find right now from variance, we find the SD standard deviation, that is Sy, it is 12. Now 30 divided by 5 into 12. 30 upon 5 into 12 means 60. 60. So 30 by 60, the final answer of correlation coefficient is 0.5. R is equals to 0.5. So student, in such short sum, no additional column we have to prepare. Just we have to put the values into the formula. Covariance xy is ready, Sx is ready, Sy is ready. Just we write the formula, put the values into the formula and get the answer. So, when question arises, here they provide us value of n also. But students, there is no any application of n here. N is 10, but there is no any requirement of it. Because in formula, we only need covariance xy upon Sx into Sy. Now, we move towards the next sum, short sum, that is sum number 13, page number 85, sum number 13. The following information is obtained regarding the height, that is x, and weight, that is y, from a sample of 10 students of S2. X bar is equals to 160, y bar is equals to 55, sigma xy is equals to 90,000, Sx is equals to 25, and Sy is equals to 10. N is equals to 10. Sir, how can you find the N? Students, read the question carefully. The following information is obtained regarding the height and weight from a sample of 10 students. So 10 students is there, so here N is equals to 10. The question is, find the correlation coefficient between the height and weight from it. Two variables are provided, height and weight. But in short sum, as I said earlier, no initial column is required. In the list of formula, my friends, we have two formulas, and we write that this is the specific formula for short sums. Two formulas are there. From that two formula, one formula is applicable here. The formula here applicable is R is equals to sigma xy minus n into x bar into y bar upon n into Sx into Sy. Now, if you see in the question, all the things are given ready. Sigma xy is provided 90,000. N is here, that is 10. X bar is available 160. Y bar is available 55. Again, N is there. Sx, standard deviation of Sx given ready. Standard deviation of Y, Sy given ready. So my friends, just for you to put the values into the formula, and here it is. R is equals to sigma xy means 90,000 minus N is equals to 10, X bar 160 given ready, Y bar 55 is given ready, upon N is 10, then Sx is 25 and Sy is 10. Do the simplification. 90,000 minus 10 into 160 into 55. Here remember 55 multiply with 160 and with multiply with 10. Final answer is 88,000 upon 25 multiply with 10 and again multiply with 10. Final answer comes 2,500. So 90,000 minus 88,000. 90,000 minus 88,000. The answer is 2,000 divided by 2,500. Final answer is 0.8. Students, in these short sums, we do not have to prepare additional problem, but remember friends, we must remember each and every formula properly. That's why first part of statistics, all the 4 chapters are based mainly on formulas, and that's why in class I always request you to remember the formula properly. All the formulas of chapter 1, chapter 2, chapter 3, chapter 4. So if any students still not yet read the formula properly, then today only you do the first work, remember all the formulas. Properly read the formulas. Because by putting only the formulas, you get the answer in such short sums. Now we move towards our next sum, that is sum number 14, textbook page number 85, exercise 2.2. Here it is, determine the value of correlation coefficient from the following data. They provide us 2 sums in the sum number 14. In first sum, sigma x minus x bar square is equals to 72, sigma y minus y bar square is equals to 32. Sigma x minus x bar into y minus y bar is equals to 45. And in second question they provide us n is equals to 6, sigma x is equals to 16, sigma y is equals to 51, sigma xy is equals to 154, sigma x square 52, sigma y square 471. If you observe students, they give us all the things ready. No need to prepare additional column, just put the formula. For first sum, sigma x minus x bar into y minus y bar is there. The formula of first method of Carl-Pearson. We do the big sums for it also, which are asked in section F of your statistics paper. R is equals to sigma x minus x bar into y minus y bar upon into under root sigma x minus x bar square into second under root sigma y minus y bar square. Now we put the values into the formula. Sigma x minus x bar into y minus y bar is 45. It is given ready. Just we have to put into the formula. 45 upon sigma x minus x bar square in under root, that is 72. Here it is given ready. Sigma y minus y bar square 32. It is also provided ready. Now we do the simplification. 45 upon multiplication of 72 with 32. 72 multiplied with 32. So the answer is 2340. 45 upon under root of 2340, that is 48. So 45 upon 48, answer is 0.94. Remember the formula, read properly formula, put the values into the formula and get the answer. Simple. Now we move second sum of sum number 14. Again, they provide everything ready. We can observe it and we remember that we have to apply the formula of xy method. the XY method, for which we also did the big sums which are asked in section F. The formula for correlation coefficient XY method is, here it is, R is equals to n sigma xy minus sigma x into sigma y upon into under root n sigma x square minus sigma x the whole square into second under root n sigma y square minus sigma y the whole square. Just we put the values into the formula. R is equals to n is 6 given ready, sigma xy given in the question 154 minus sigma x is ready 16, sigma y is ready 51 upon into under root n is 6, sigma x square is ready 52 minus sigma x the whole square 16 the whole square into second under root n is 6, sigma y square given ready in the question, that is 471 minus sigma y the whole square 51 the whole square 145 154 into 6 924 minus 816 upon into under root 312 minus 256 into second under root 2 into 6 minus 2601 924 minus 816, that is 108 upon into under root 56 into 225 108 upon multiplication of 56 with 225. The answer comes 11225. Now finally 108 divided by under root of 11285 11225, the final answer is 0.96. So students, here it is the short sums which are asked in linear correlation. In next video lecture, I take the further more sums, short sums, for the practice of such short sums. I am confident that you all are able to understand this particular short sum and able to do yourself also. Thanks for your cooperation. Thank you again.